All right. Okay, so from our booklet about exponent properties, we're going to go back to the front because we skipped over one of these properties. And this is the one that's new to us this year for Algebra 2. It's properties of rational exponents. And what we mean about that is fraction exponents. Okay? So in our class, we get to look at what it means when an exponent is a fraction and how we simplify that. Okay? And we kind of did that yesterday. We had some where exponents were fractions, but we didn't have to really deal with the fraction part. Okay? But when your exponent is a fraction, whoa, come on. When your exponent is a fraction, the numerator and the denominator mean something, okay? So here's our example. Here's an exponent, that's a fraction. The denominator of the exponent, that tells you the type of root. Okay, that tells you the type of root. So if the denominator is 2, it's a square root. If it's 3, it's a cube root. We've kind of talked about that already, okay? The numerator of the exponent, that tells you really the exponent. That's the exponent part, okay? So if you have something that looks like a fraction exponent, you can rewrite it in one of two ways, okay? Notice both of these are the same in that the denominator is the root, right? But when it comes to the numerator, the exponent, you can either put that under the root, like this example, or you can put it outside the root. They mean the same thing, okay? Now typically, whenever a is a number, when a is a number, we like to do it this way. When a is a number, we like to do it this way. When a is not a number, then we typically we put the exponent underneath, okay? So for instance, if I had 9 to the 3/2 power, okay? Let's say I wanted to evaluate that. That's a number, 9, right? So we can write it in one of two ways, okay? If I do the first way, I would rewrite this as the square root of 9 to the 3rd power. Okay, so if I do it this way, now I have to figure out what's 9 to the 3rd power, and then I have to square root that. Can you do that without a calculator? I can't. I can't do 9 to the 3rd power and then take the square root of it. Okay? Or I can write it like this. The square root of 9, and then take that answer and raise it to the 3rd power. That way is a little easier for my brain to do. Do we know the square root of 9 without a calculator? I hope. What's the square root of 9? The square root of 9. What number squared makes 9? 3, right? 3 squared makes the number 9. So this would be 3 raised to the 3rd power. And 3 to the 3rd power, 3 times 3 times 3 is 27. Whoops. Now this first one is 27 as well, but that's harder to figure out, okay? All right. So using this, we can use this idea of what radical and rational exponents mean in order to simplify some things. So now let's go in the notes booklet and find examples 6. Okay? Okay. So the directions for this whole thing is simplify. Okay? All right, so I noticed that we've got a root, and I'm trying to find the cube root of all of this stuff. Now, maybe you know the cube root of 27. I kind of hope you know the cube root of 27. We were doing it a lot, right? But the other things are kind of difficult. So what we can do to simplify this is we can write these right as rational exponents. Okay, because once we turn them into exponent form and they're fractions, then we can use all of our simplifying fractions rules to simplify this, okay? All right, so everything that has a exponent, that's the numerator, the exponent numerator, and then this root is going to be our denominator, okay? So we're going to have 27 to the 1/3 power. Everyone know where the 1 and the 3 came from? 1 is the power, 3 is the root, so 1/3. And then I can go x to the 6/3 power, because 6 is the exponent, 3 is the type of root. And then I would have y to the -9/3 power. Okay? Everyone okay with where all of those fraction exponents came from? Top number is the power, bottom number is the type of root. Okay, now if we have a number, we should be able to figure that out. So cube root of 27. What number cubed is 27? We already did this one. 3, right? So this, and if you didn't know it, you could just type it in the calculator, right? You can't type these in the calculator, but you can this one. So this is 3, okay? Now we look at our exponent on x, and we have 6/3. Can we reduce that? Okay, thanks. Just put it there, and I'll... Okay. 6/3, what does that reduce to? What does that reduce to, Alberto? 6/3. 6 divided by 3. 2. Yep. So it's just x squared, okay? And then y was -9/3. -3. Okay? That's why we do this step of turning it into the fraction exponent, because when they're fraction exponents, we can simplify them. Okay, now, we never ever leave a negative exponent in our answer, right? A negative exponent tells you reciprocal, so you have to change where y to the 3rd is in the fraction. So our final answer is going to be 3x squared over y to the 3rd, because negative exponent means move where that power is located in the fraction. Okay? Okay. I'm giving you a chance to try one. The other number 6 has the exact same steps. Okay? What kind of root is that? It's not a cube root, it's a what? It's a square root. Okay, let's go over this one. So it's a square root. So all the denominators of your exponents are 2. Okay, so I have 16 to the 1/2, x to the -4/2, and y to the 10/2. Okay, 16 to the 1/2 power, that's square root of 16. What's the square root of 16? 4. Okay, now we can simplify this one. This will be x to the, what's negative 4 divided by 2? Negative 2, yes. And then I have y to the 5th, because 10 divided by 2 is 5. Can we leave our answer like that? No. Anything with a negative exponent, so this has to move its location in the fraction. So that means it's going to go to the bottom of the fraction. So final answer, on the top you have 4y to the 5th, and on the bottom of the fraction you have x squared. That's the final answer. Okay? Okay, now those worked out nicely because look at all of these exponents. They could divide nicely, right? 4 divided by 2, 10 divided by 2. But what happens when it doesn't work out that way? That's our last example of these. Okay? So let's look at number 7. This is a 4th root. Okay? There's such a thing. You can have any kind of root you want. Okay? So that means the denominators of the fractions will all be 4. So let's rewrite it. 16 to the 1/4, x to the 5/4, y to the 3/4, and z to the 12/4. Okay, now let's go and let's try to find our simplified versions, okay? So 16 to the 1/4 power. Anybody happen to know what that is? You could type it in. It's 2. 2 times 2 times 2 times 2 is 16, okay? So it's 2. All right, now I have 5/4. You can't divide 5 by 4 evenly. But y'all remember from like, I don't know, what is it, 5th grade, 4th grade, where you would do like improper fractions and mixed numbers, right? 5/4, isn't that just 1 whole and 1/4? Y'all know where that came from? Because 4/4 is a whole, and then you have 1 left over. Okay, try to think back to like 4th, 5th grade when you learned about that, okay? So I can rewrite this as x to the 1st power, and then x to the 1/4. This is the same thing as these two put together. Does that make sense? Okay. Y to the 3/4. Well, you know what? I don't have, that's not an improper fraction. I don't have a 1 whole in that. So I'm just going to leave it as y to the 3/4. And then z to the 12 divided by 4, that's 3. Okay, now I'm going to look for all of my whole number exponents. Okay? So that would be 2. That would be x to the 1st power. And that would also be z to the 3rd power. Okay, so I'm going to grab everything that has a whole number exponent. Okay? And I'm going to write that first. And everything else that didn't have a whole number exponent, I'll make that green. Everything else that didn't have a whole number exponent, these two, those are going to have to get trapped back under the 4th root. Okay, so they didn't make a whole number exponent. So I'm going to draw my 4th root, and I'm going to put these guys back under the 4th root. So what goes under the 4th root? X to the 1st power, or just x, and y to the 3rd. So everything that had a whole number exponent came outside, and everything that didn't make it was stuck inside. This is how you simplify square roots. But you were always looking for pairs because it was a square root. Well, now I'm looking for 4/4 because it's a 4th root. Okay? So this is the final answer for this one. Okay, why don't you take a second and try the other number 7, see if you can do that. So write them as fraction exponents. Look for all your whole number exponents. Bring those out. And everything that is left over gets stuck back under the root. And by the way, 64 to the 1/3 power, or the cube root of 64, is 4. Okay, so let's start going over this. So 64 to the 1/3 power is 4. Now, I want to work with a to the 5/3. So let's try to make that into a mixed number. 3 goes into 5 one time. How many are left over? 2. So that's 1 2/3, right? So I have an a to the first, and I have an a to the 2/3 power. Okay? Now I go to b. 9 over 3. That one will simplify perfectly, right? 9 divided by 3 is just 3. So I have b to the 3rd power. Okay, now 8/3, that does not simplify as neatly. So let's try to make that into a mixed number. Okay, how many times will 3 go into 8? 2 times. That's 6. And how many are left over? 7, 8. 2 left over. So it's 2 2/3. So I'm going to have z squared and z to the 2/3. So all the whole numbers and then the remainders are stuck over the root. Okay, now I look for all my whole number exponents and I write those first. So I've got 4 and a. I'm going to pull that out. I could do the 1 or not. And I can also pull out b cubed and z squared. B cubed, z squared. Because those all have whole number exponents, right? And then everything else that has a fraction exponent, so this one and this one, they get stuck back under the cube root. So now I'm going to write cube root. And what goes under the cube root? A to the power of 2 and z to the power of 2. Because remember, the numerators tell you the exponent. Okay? And that, although it looks weird, you might think, how is that more simplified than the original problem? It is, because we rationalized some part of this, okay? What questions can I answer for you about these? Okay, I just want to pick out just a couple of these down here. Like, I want to do, so these evaluate with numbers. These are just ways where we can easily come up with the answers to these without having to use a calculator. Okay, so like, let's look at 11. Using what we know about fraction exponents, we can easily get the answer to this, okay? First of all, we know that the 1/2 power can go to the numerator and the denominator, right? And we also know that a 1/2 power is the same thing as what kind of root? What kind of root is the same as a 1/2 power? Square root, right? So this would be the same thing as the square root of 1 over the square root of 25. And we know what those things are, right? The square root of 1 is 1, and the square root of 25 is 5. So without a calculator, we can just figure out that that one is 1/5. Okay? Okay, and using that, we can also do something like this in number 12. So I know that I can give this to both the numerator and the denominator. So I can choose to look at this as the square root of 9 to the 3rd power over the square root of 16 to the 3rd power. Because remember, I can put the numerator either under the root or outside of it. I just have to think, what is easier for me to do in my brain if I don't have a calculator? I want to put it outside. So the square root of 9 is 3. So I'm going to have 3 to the third power. Over the square root of 16 is 4. So 4 to the third power. 3 to the third power is 27, and 4 to the third power is 64. Okay? Okay, and we'll do one last one because this is, number 13 is a lot like a few of one of your slides on your assignment. Okay, so this says rewrite because we can't get an answer, a number answer like we could over here. Okay, so we're gonna rewrite this in a few ways. Okay, first way would be just like we did here. That means square root b, and then this is the exponent. Now where can the exponent go? It can go on the outside or on the inside. So here's one way we can write our answer like that, right? The other way we can write our answer is to put the exponent on the outside. There's another way. That's equivalent. And then another way is to look at this 3 over 2. Can we write that as a mixed number? 3 over 2, isn't that 1 and 1/2? I could look at this as b to the first times b to the 1/2 power. So I can pull out the whole number exponent and just have the square root of b to the first power as the other one. 3 different ways of writing the same thing. Okay? Okay, I know it's a lot of like exponents and stuff, but are there any questions over what we've done that I can answer for you? Okay. How about as you work through your matching, if you get stuck, let me know. Okay? All right.